Hi, welcome to video 10.4e part 2, more on polar tangent lines. Okay, so just to review very quickly, the slope of a tangent line to a polar curve is going to have to be dy over dx, which will be dy d theta over dx d theta. You'll be given r equals f of theta. You'll have to come up with an x and a y in terms of theta by using x equals r cos theta, this being your r, and y equals r sine theta. So here's another example, r equals 2 plus 3 sine theta. So first I'm going to get x and y in terms of theta. So x is r cos theta, well r is 2 plus 3 sine theta times my cos theta, distribute, and that's what I get. Y equals r sine theta, well there's my r, times sine theta, and distribute. So now I'm going to find the derivative dy d theta. So I'm going to take d theta on both sides of this. I'll get 2 cos theta plus 6 times the sine of theta times the derivative of the sine of theta by the chain rule. From this one, x is a function of theta, I'll be able to take d theta of each side and get dx d theta equals negative 2 sine theta. And of course here I will have a product rule. So it's going to take a little bit of work, blah, 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 blah. There's dx d theta. So my dy dx is going to be this red dy d theta over this green dx d theta. And therefore, you will then, when this derivative is equal to 0, you'll have a horizontal tangent line. When it does not exist, you'll have a vertical tangent line. Okay, 63 to 64, find dy dx and the slopes of the tangent lines as shown on the graph of the polar equation. So they're asking you to find 3 of them. It's pretty obvious. This one looks like it's going to be horizontal. That one looks vertical, and that one you're not sure. So let's take 64. You have r equals 2 times 1 minus sine theta. Let's distribute. I don't know why they leave it factored. So you can see, by the way, they're giving you the curve. The AP is not going to do that. You should be able to figure out that this is a limacon. It's symmetric with respect to the vertical axis. And if you plug in 0, pi over 2 pi, and 3 pi over 2, and check for the pole, you'll realize it has 4 intercepts, one of which is the pole, so it has to be a cardioid. Okay, so the question is, find the slopes of the tangent lines, these 3 blue tangent lines. To get the slope of the tangent line, I need dy dx. To get dy dx, I need dy d theta over dx d theta. I need r, x in terms of theta, and y in terms of theta. So x is r cos theta. Here's my r, multiply through. And if you can notice that that's sine 2 theta, it's just going to make it easier to take the derivative later. So dx d theta is negative 2 sine theta minus the cosine of 2 theta times 2. But we also need y. We need dy d theta, so we need y in terms of theta. So we have y equals 2 minus 2 sine theta times sine theta, multiply through. Dy d theta is 2 cos theta minus 4 sine theta times the derivative of sine theta, which is cos theta. Again, I'm going to rewrite it as 2 cos theta minus 2 sine 2 theta. Okay. So therefore, dy dx, since it's equal to dy d theta over dx d theta, here's dy d theta. Dx d theta is this guy right here, so I put that down here. And you can see that I can factor out a 2 and cancel those 2 2's. I'll be left with cosine theta minus sine 2 theta over negative sine theta minus cos 2 theta. Their question is, what is the slope at these 3 different points? So, and the one thing I don't like is that they don't tell you if these are rectangular or not. Now, it's pretty obvious that they're polar points because the point 4 comma something in rectangular would never end up on the y-axis. So, the other thing that gives it away is that this is pi over 2. And it tells you it's a graph of a polar equation, so we're assuming the points would be r comma theta. Okay, so we're ready to plug this in. The only thing is, oh yeah, it's in terms of theta. So at the point 2, 0, we're plugging in theta equals 0, and we will get negative 1, and it sure enough looks like